everyone, I'm going to show you a tutorial in G-Power. This will help you determine the suggested sample size for your study. So first I'm going to show you how to access the G-Power software. It is a free software for PC or Mac, and you can navigate to this link above. Or you can Google G-Power software and choose the first option here. It's from a university website. So let's go ahead and do that. I'll actually split my screen here so you can see multiple things. And when you get to the site, you can scroll down to where it says download. Then you can review these terms of use and download which one is appropriate for either Windows or Mac. And then you'd launch the program. If anyone is using a Chromebook, please make sure to meet with your group members who have either a PC or a Mac. You can let us know if you have any issues with that. Okay, so I just want to let you know I'm going to be using remote desktop to use G-Power just because my computer cannot download it on its own, but it should be able to download on your personal computer. So you don't need to use remote desktop. You actually probably can't for this program, so please download it on your personal computer or get together with a group member who can download it. Okay, so we are going to focus on 3 tests using G-Power during this tutorial. They are all located under the test family F tests. And it might be because during your project this semester, you might project to use an ANCOVA or an ANOVA or a linear multiple regression, more so moderated regression for your project. And so you'd locate those under F tests, and then it's that first option there, ANCOVA, the second option, which is a one-way ANOVA, and then down here, it's the linear multiple regression fixed model R-squared increase. Okay, so let's see the next slide here. The type of power analysis we're using is called a priori, and it is where we'll compute a required sample size given the alpha significance level, the power, and the effect size. A priori simply is we're using what we know to determine probable results. We'll use the alpha level, the significance level 0.05. So anytime it would ask you an alpha, you'd put in 0.05. And when it's asking you power, you'd put 0.8. The power, in this case, this means that there's 80% of a chance that the results are showing some kind of probable real effect. Okay, but we also need effect size. So how do we figure out the estimated effect size measurement and value? Well, we look to our literature. And so just to bring this up here, you're looking for an effect size within literature that you're reading that most closely resembles to what you're actually studying. And so that means that the variables in the literature are closely related or the same to your study. And then you'd go in the results section and find the effect size. So I'll split this again and bring up just an example study here. So the results section of this study says that they performed an ANOVA that yielded a main effect of groups. So there were 2 groups. And here you see that the effect size is reported in partial eta squared as 0.08. So we'll come back to this later, but that is one way you can find it there. You'd also find some other parameters that you'll need for G-Power within the literature that you're using. Okay, so on to the next slide. Something you need to know is that G-Power may ask you for an effect size in a measurement that the literature you're looking at did not actually report. So I'll split the screen again and just show you an example in G-Power. The effect size here, if you're using an ANCOVA, actually asks for F, Cohen's F. So if if the literature you found does not say F, like for instance, mine said partial eta squared, because they did an ANOVA, a one-way ANOVA there, I still need an F, not a partial eta squared. So we have to use a converter. And so now please go to this site. It's effect size calculator, sort of a converter. And what it would do is that you put the effect size you found in your literature in here to convert it to one that you might need for G-Power. So I'll show you some examples. Basically, if literature reports one effect size, but G-Power requires another, you should convert it. So for an example, if literature reports the effect size as R squared and it's 0.4, I'm going to type in 0.4 into R squared, press enter, and you'll see all the numbers have changed. But G-Power requires perhaps F squared as the effect size. So what that means is it's Cohen's F squared is what it's asking for. And so here we don't have F squared in the list, but what we would do is convert to F. So we'd convert R squared to F using this website, which is 0.816. F equals 0.816. And then we would square it. So I'm going to bring up the calculator just simply here and say 0.816 squared is 0.666, really, 667 here. And so your F squared from your R squared would now be 0.667. So that's the number that you would put into G-Power if it asks you for an F squared. So I'll show you a few more examples of this, okay? So for instance, there's another way to convert effect size. You don't just have to use this site, but this is one way that you can convert it. Let's go to G-Power. It actually has a calculator sort of inside of it, but it's a little bit more confusing and it doesn't give you all the options. That's why I'm giving you two ways to do this. So in G-Power, let's see if we're trying to convert an R squared to an F squared. I just showed you how to do it with the calculator, but in this example, we're going to use G-Power. So let's go to F tests and then linear multiple regression fixed model R squared increase. So down here, we're going to, let's see the next point here. So here, if we don't have F squared, because the effect size it actually asks for is F squared, but we have R squared from our literature, click determine. That's right next to the effect size, so in the input parameters. So when we go to determine, it brings up this second dialog box. And in that dialog box, you would enter the R squared value that you found from your literature in the variance explained by special effect box. And so if you recall from the last slide, it was 0.4 was the R squared that we found. And then step 3, enter a value of 1 minus R squared in that residual variance. And so 1 minus 0.4 is 0.6. So we do that. Then we click calculate and transfer to main window. And so when you click that, you can see the calculate says an effect size of F squared is now 0.66 repeating. And it transferred it back to the main window. You can see, you could type it in yourself, but now it has been determined. And if you recall in the previous slide, that is what we determined from the effect size calculator website, that it was about 0.667. All the conversions are approximate, so it's not going to be exactly the same, and that's okay. Okay, so for another example, using G-Power to determine the correct effect size, let's go to F tests, and then we'll use ANOVA, one-way ANOVA, fixed effects omnibus one-way. So what if you don't have F, which it asks you for, but you have eta squared? So let's click determine, like we did here, and scroll over to this window again. And in the new dialog box, select procedure up here, effect size from variance. So now we're here. then enter eta squared in the variance explained by the special effect. So let's say here we go, the eta squared is, let's see, 0.15. And then in the variance within groups, we're going to enter 1 minus eta squared, and that's going to be 0.85. And then let's say calculate and transfer to main window. So we'll scroll over, and there we go. It's right in there as 0.42. So that's just an example, of course. You're getting your effect size estimate from the literature, and you're converting it if necessary, determining what statistical test you're using and what effect size they're actually asking for right here. Okay, so those are just a few ways to convert. Let's pause just for a moment from this, and I want to show you some examples within GPower. So as we said, one of the things we're going to use is an ANCOVA. And so like we said, I already showed you how to enter and find your effect size F that it asks for. We already know we're going to use a 0.05 alpha level, and our power, we're going to use 0.8. Of course, higher power is always better, but 0.8 is sort of what scientists are satisfied with when you're saying if you have at least 80% power, that is good. So then you also need to determine your other parameters here. And so this degrees of freedom numerator is actually the number of predictor variables. And so you're going to determine that, as well as the number of groups in your study and the number of covariates. And when you calculate it, when you click calculate, then you'll see in the output parameters the total sample size that is suggested from your power analysis for you to have enough power to have a sample size that you were looking for in your literature. I'm sorry, the effect size that you were looking for in your literature. So this is just showing you how to input parameters and get your total sample size. So let's show you an ANOVA. And I'm actually going to cut this down and bring up the literature that I found here for ANOVA. So in this case, if our effect size was the partial eta squared as 0.08, right, we're going to need to calculate that, let's see, into an F here. And if we go over to the determine, we'll calculate effect size. And it actually says directly, if you have a partial eta squared, let's put it in. So this literature says 0.08, right? So I'm going to put in here 0.08 and then calculate my F. So let's calculate that and transfer to main window. So there we go. So we're putting in 0.05 and 0.8 there for power and the number of groups. In this case, the study said that they were testing an ANOVA and yielded a main effect of group. And there were 2 groups in this study here. So we're going to, let's see, calculate, and it says that the total sample size would be 94 participants here. So to show you linear multiple regression, fixed model R-squared increase, very similar, right? You'll calculate your F squared. Let's see, say it's a 0.3, 0.05, and then 0.8 for power. So in this way, how I want to describe, sorry if that was a little bit confusing there. The reason why we're using linear multiple regression fixed model R-squared increase is because there's no exact way through GPower to determine, do a power analysis for a moderated regression, which is what some of you will be, the way that you will be analyzing the test that you'll use. And so the way that we mimic that is by using this statistical test, linear multiple regression fixed model R-squared increase. And we actually fill in these parameters, but what we're doing is saying that the number of tested predictors will be 1 because you're acting as though that is your moderator. We're just going to test one variable when you're talking about your moderator, and we'll put in 1. And then you say the total number of predictors. And so the total number of predictors potentially could be 3. So you have to figure that out. And so when you calculate, says in this case, the total sample size would be 29 here. So make sure you're looking at your literature to determine what effect size you'll need to enter into GPower. And also, of course, beforehand, you'll need to figure out which statistical test you'll use. Okay, let's get back to the PowerPoint here. Some things we want to note is that your study effect size estimate is most likely going to differ from the effect size that you had looked at and found in literature. What you observe later on in your study won't be the same. And basically, it's because your study is not an exact replication of that literature that you're using. There's most likely a different collection method, a different population, and you'll have access to a smaller sample size. And so, of course, smaller sample size will yield differing results than a larger sample size. The other thing is that you could read more on this in the reference here, but over time, many publications were really only published if there was significance. However, all of the studies that were not published because they were not significant still need to be published, and the scientific community is working on that to, of course, disseminate knowledge across the psychological community. And so what has happened over time is that publication bias reported effect size estimates that are usually overestimates. And so that's one reason why perhaps what you end up observing as your effect size estimate in your study will likely be different from the effect size that you found in literature. And so, as I already mentioned, you'd finalize the parameters within GPower to receive your suggested sample size, right? And it'll be right there. And pretty much whatever that says, it's saying at least this sample size is suggested to have enough power to conclude that there's a real effect in your study. And so go ahead and do that for your group project, and we can talk about it with your professor as well. Thank you so much.